Hello.
Yes, Zoha, am I audible now?
Yes, ma'am, you're audible.
All right. Yes, Zoha. So in the last class, we had started with the lens, and yesterday we couldn't have our class. Let's complete this portion today. So basics of the tips for drawing ray diagram we have seen. Now let us actually see the ray diagram. As I've told you in the last class that I'll be just pasting the picture so that it saves our time. See,
Okay.
when the object is kept at infinity, so now the position of the object, this is at infinity. Again, the way we have seen this in the case of the mirrors, same thing we'll be seeing it here. The parallel rays come, they intersect at a point. This is the focus. So when the ray is parallel, it passes through the focus. That rule is valid here also. So what would be our image distance? What would be the image? Image would be formed at the focus F2. So image would be at F2, which would be the focus. And what would be the size of image? You can directly see if the rays are coming from infinity, they are parallel. So this is very small. So this is highly diminished.
Yeah, highly diminished.
This is highly diminished, or you can say point size.
Yeah.
Fine. And what about the nature?
The nature, it's real and
Nature of the image, this will always be real and inverted.
inverted.
Real and inverted. One more case, C class. If we have the object beyond 2f2, see again we will start from there. We have infinity, rays are coming from infinity. Fine, then we'll bring the object a little closer. See what we'll do. We have brought the image a little closer. Now, when we are bringing not the image, sorry, the object. When we are bringing the object a little closer, see earlier it was at infinity. Now here we have the object. This is the object distance from the optical center. This is the object distance. This is the image distance. This is the image distance. Now, where have we kept our object? We have kept it beyond 2f2. Right? But where are we getting our final image? We are getting it. This is not exactly beyond 2f2. You can say here, if this is beyond 2f2, then this is between. Actually, this is not clear. I'll just mark it. Here we have our f2. This is 2f. Fine. Or you can even look at this one. This is f2. This is f1. So where is our image form between f2 and 2f2? So where is the image formed between f2 and 2f2? Can you tell anything about the size, Zoha?
The size is just small. The size
It's
is
small. Size is small.
Yeah.
This is diminished only.
Yes.
Size is small. And when we are talking about the nature, it is again real and inverted. See, this is the image, but this was the object. So this is real and inverted. Fine, write down these two cases first, then I'll discuss some more.
Okay. Can you scroll down?
Written this part, Zoha?
Yeah, I wrote it. Okay, ma'am, I'm done.
Zoha understood till here?
Yeah, I understood.
Okay, let us see some more cases now. Look, in the third case, what we have done, we have kept the object exactly at 2f2. So where is the object? It is at 2f2. See, this is 2f2. So this is exactly at 2f2. So this becomes our object distance.
Yeah.
Now look here. When this ray is passing through the convex lens, it is converging it at the focus. Second ray is passing through the optical center, it is retracing itself the way we have been drawing it through in the case of center of curvature. Now, where is the image formed? Image is also formed exactly at 2f, but on the other side of it.
Yeah.
This is formed at, this was 2f1 actually, this is 2f1. So when we'll be drawing this, so that there's no confusion, which 2f is this? This is 2f1 and this is 2f2. This is the second one. Here we are getting, right? This is 2, this was 1. And again, what about the size? Exactly same size.
Yeah, same as
The
the
way
object.
this is similar to that case of the mirror, where in the concave mirror, do you remember when we had placed the object exactly at the center of curvature? We used to
Yeah.
get the image at the center of curvature of the same size. So this
Yeah,
is
we did.
similar to that. So size will be same as that of object. And when we are talking about the nature, it is real and inverted. This is real and inverted. Now the next case. See here. This is our object between F and 2F1. F, this is the focus one, F1. This is 2F1. And we have kept the object. See, we have initially brought it from infinity. Then beyond F2 we have kept. Then at F2 we have kept. Now between F1 and 2F1 we are keeping it. So one ray gets converges through the mirror. Second ray passes through the optical center and it retraces itself. Here we are getting image where this is beyond 2F. And what is the size of image? This is enlarged. This is enlarged than the object. And what's the nature? See, real and inverted. This is real and inverted. Right? So this is the next case. One more case. Now look here. Then between 2F1 and F1 we have already kept. Now we'll move it again a little further to the lens. Now where are we having the object? Object is at F1. Now what is happening when the object is at the focus images? Where are the images formed? Infinity. So this is that case. See, here what is happening? In the previous case, we had seen that whenever you have the light rays which are coming parallel, so they pass through the focus. Now this is at the focus. So when we are talking about the image, this is formed at infinity. Fine. And then what about the size of image? Now size will be highly enlarged. See, something is formed at infinity. So it would be very, very large. So this is highly enlarged. And nature would be again real and inverted for all these cases, real and inverted. These are the mirror diagrams, ray diagrams for the convex mirrors. Cave we have to see. One special case is there. One special case also, let us discuss. Look here. This is a special case. Why? Because till focus we had already covered. Now what we are doing? We are bringing the object more closer. We are bringing it closer to again the lens. So this is the optical center. What is this O? The O is our optical center. 2F1, 2F1. So this is our object. This is the object. See, this is the object distance. Now what happens when this ray passes through the focus, second ray passes through the optical center, retraces itself. Then we have to produce it here. This is A dash, B dash. This is the image that is formed. So where is the image formed? Image is, this is the object between focus and optical center. Image is formed on the same side of the object, or you can say in front of the lens where the object is formed. Same side of the object. Fine. And size of image is enlarged and nature is virtual and erect. So this is the only case where you get virtual and erect case. So all these were the images of a convex lens. Tell me, Zoha, all these cases are clear to you?
Yes, but like for identifying the position of the image in this one, can't we write the images between 2F1 and F1?
Which one? Which one?
For this one, the sixth case.
Can't we write what?
Instead of writing like in front of the mirror or on the same side of the object, can't we write in between 2F1 and F1?
No, because it's not necessary that it is formed between F1 and 2F1. It can be formed anywhere on this side where the object is present.
Anywhere. It doesn't have to specifically form there. Sits on the same side of the mirror.
Yes?
So it has no specific place where it will
No,
form.
no. No, it has no specific. Like we right now beyond to F1. So that is also not specific. It is beyond, it can be anywhere. This is similar to that. It is formed on the same side. It depends upon the object's height, object's length, distance of the object in front of the optical center, the focus. So that's why you do not get one specific. All the specific points we have discussed. Right. So this is anywhere on the side, anywhere on
Okay.
the same side in front of the lens where the object is, anywhere. It's not, it could be at 2f1 also, it could be beyond 2f1 also, it could be at 2f1 also. Fine.
Yeah, fine.
Okay, just write down all these cases. Any doubts you have, please let me know.
Okay, ma'am. Can you scroll down? Can you scroll down? Can you scroll down? I finished drawing the images.
Yes, Zoha, done?
Yeah, I'm done.
Okay. Any questions? Any queries till now?
Mm, yeah, can you go to the first case?
Yes, wait. This one?
Yeah, like where the nature of the image, right? How can
Yes.
we say it's real and inverted? Like we
See,
can't tell.
this is actually calculated. This first case is seen experimentally only. When you have this experiment done, no, then when you move the lens, you can see a little very blurred image which is inverted. So the first case in all of these, wherever the image is diminished, wherever you see the image is diminished, that is never calculated through the ray diagram. Okay. And also,
Okay.
this is the first reason that this is done experimentally. So experimentally, we know that this is real and inverted. Second point, that what is the function of a convex lens? It has the function of producing a real and inverted image. So by default, also we have the real and inverted image. That's why for the sixth case, we were saying that was a special case. So by
Yeah.
these points, we can say it's real and inverted. Clear?
Okay. Yeah, got it.
Okay. See, for concave lenses, we have very few images
Yeah, like
present.
it has similar properties of the convex mirror, I think.
Yes.
It has similar properties to convex mirror, right?
Right. It has similar properties to that. And the way in the convex mirrors, we have seen it was very less. The case was just one or two cases we had seen for the convex mirrors. So this is the case of convex lens. Sorry, not convex, concave
Okay.
lens. See, in mirrors, concave mirrors are more important than convex mirrors. But in lens, we have convex mirrors more important than the concave lens. So here also, I'll just show you.
So wait, so concave mirrors are more important and convex lens are more important, right?
Yes, concave mirrors and convex lens. More
Because they
important
have
in the sense, more important from your examination perspective.
yeah, because they
Okay.
have more examples, unlike the other
In
two.
the exam, the questions are often asked from the concave lens, from the concave
Mirrors?
mirrors
And convex
and the
lens.
convex lens. These are more asked in the exam. Anything can be asked though. Concave mirrors are also asked, convex mirrors are also used, concave lens are also asked. So anything can be asked. That is different, but we have no some topics which are important. We mark it out so that it becomes easier for us for the exam perspective. So for that from that perspective, we have that. Now, see, for the concave lens, firstly, where is the object kept? Object we have started from
At
infinity.
infinity.
Yes. So again, it has the now the difference is that these rays are diverging rays.
Yeah, the diverging.
Yes,
So
you can see they are
when you
now in
produce
different
the
direction.
rays, they meet
When
at
we had the convex, they were like this. Remember, converging at the focus here. Like this rays were converging at this point. Now see, when the rays are coming, they are getting diverged. Look, can you see this difference? They are getting diverged.
so this concave lens is a diverging lens and
It's a
convex lens is
diverging
a
lens. And
converging
the
lens.
convex lens is a converging lens. We have discussed that in the last class. So
Yeah,
these
we
are
did. Just wanted to
converging,
recall.
these are diverging rays which are. So
Yeah,
what
diverging.
happens? This ray gets diverged, but when you produce it, you see the rays are getting focused at the F1. So our object was at infinity, but again our image is formed at F1 here. This is it. And size again, you can say it is highly diminished. Size is highly diminished, or you can even use the term point size. This is highly diminished, or we can say this is point size. Now again, the fact of the nature. See here also you cannot see anything from the ray diagram. So
Yeah.
one thing, these are calculated experimentally. So from there we can conclude and we have the data. Second is that the properties of diverging lens, that is the concave lens, they have the property of forming virtual and erect images. So that's why this one would be virtual and erect. All right. And then one we have between infinity and any point in the optical center. You don't have any specific points for this. I'll show you the diagram. Wait. For the concave lens, that's why we say for remember, do you remember when we were doing convex mirror, the last one which we have done? There we had only
Yes.
one case, which was the one where anywhere the image was formed. Remember this, Zoha?
Yeah, we did.
Yes. So similarly, here in the concave lens, we have this case. Now, the second case is very simple. Anywhere you have between infinity and this optical center, between infinity and optical center, anywhere if you keep the object, you'll always get the image here between the F1 and the optical center. Object is anywhere, but the image is formed here in
Okay.
front of the mirror. The image is formed between F and O. Also add in front, not the mirror, sorry, in front of the
Lens.
lens. Yes, this is formed. And see, size is small, very small, but not diminished, highly diminished, and it's not enlarged. You can see from the ray diagram also. And this is virtual and erect. See, this is exactly erect. Head, head, tails, tails. So these are the two cases.
Okay.
Fine?
Yeah, fine.
Okay. Write these two down, then we'll see lens formula, the way we have seen mirror formula.
Okay. Can you scroll down? Ma'am, I finished.
Okay, Zoha, remember we have done the mirror formula. What was the mirror formula?
Mirror formula was 1 by f equal to
Yes. Is
mirror
equal
for
to
1 by f is equal to 1 by v plus 1 by u.
yes. And V was the image distance and U was the
And u is
object.
object distance, yes.
Correct. Here we have the same thing. See, 1 by V would also be there, 1 by U would also be there. But we do not have positive sign that you can interchange. Here is a negative sign. And you know, in subtraction, you cannot subtract any of the two things which you want, right? So here, this is 1 by V minus 1 by U. That is the complete formula, lens formula.
We just switch
Lens
signs.
formula is 1 by V minus 1 by U. What
Okay.
what are all these things? I'll tell you. See, you know what is O? O we have already
Yeah,
taken.
optical
O
center.
was the optical
Center.
center, right? Now
Yeah.
focus is the distance between the focus and object. This is the
Focus.
distance between focus and optical center. Then what is V? It's the
Is the
distance
image distance.
between, yes, image
Distance.
and O means from the optical center.
Yeah.
The way we have been taking it from the pole of the mirror, now we'll be taking the distance from the optical
Yeah.
center. So this is distance between object
From the optical center.
and O. Yes. Again, this relation remains the same. Focus is equal to radius of curvature by 2. This is valid
Yeah.
here also.
This is also.
Here R is our radius of curvature. This relation is valid for the mirrors as well as for the lens. But here you have this negative sign, so you have to be careful. There in that mirror one, you could add any of the two, right? 1 by V plus 1 by U, you can say, or 1 by U plus 1 by V. Answer is the same. But you know, if you have 1 by V minus 1 by U, 1 by U minus 1 by V, these are not same because you can get one answer as negative. So you have to be careful. These are also the same. This when we are talking about the magnification, one formula is the same when we are talking about magnification. Same thing. Height of image by height of object, this is there. But there is just slight difference. When we had magnification for the mirrors, we had minus V by U. Do you remember minus V by U?
Yeah, minus V by U.
Yes. Here we do not have minus V by U. Here we have simply plus V by U.
Okay.
So that negative sign has. This is simply V by U. So you have these two. Again, the conclusions are the same. When M is greater than 1, we say it's magnified. Same thing. If M is equal to 1, then same size. If M is less than 1, then diminished. Fine, this is regarding the magnitude. And regarding the signs also, if
Yeah.
it is positive, it's virtual and erect. If it is negative, it is real and inverted.
Real and inverted. Yeah.
Yes, this is real and inverted. Now, one more thing I'll tell you, Zoha, to just help it in your numericals. When you have the focus, object distance, when you have to use the sign convention, because you'll always put the sign convention. See, for concave mirrors, what you can do, let me just make it in a form of table. Just wait, just wait.
Okay.
Okay. Look, we have the focus, we have the object distance, we have image distance. So when you have the concave lens, look, focus is negative for a concave lens. Remember, it is formed in front of the mirror. So in
Yeah.
front of the lens, and in front of the lens, we take it as negative. So this
Yeah.
is negative. Object will always be in front of the lens, so it will be negative. And image also, for the convex lens, we have seen it is always formed in front of the image. So virtual image always, because we are getting virtual image.
Yeah.
We had seen no case where real image was formed. Two cases we have seen. In both the cases it was this. So this will help you. Even if you're getting a wrong answer, this will help you get your sign conventions clarified. And then you have convex lens. For convex lens, the focus was positive. Focus was positive. Remember, it was formed behind the lens. But object distance will always be negative, because this is object will always be kept in front of the lens. You cannot keep
Mom.
the object behind the lens, no, behind the mirror or behind the lens. Object
Yeah.
distance is always negative. Regarding image, we have two cases. We have seen it is positive also, it is
Or
negative.
negative. Yeah.
So this would be. Zoha, one more thing I wanted to ask. Are you not submitting any homeworks? I have seen, I'll show you also. I haven't received any of your homeworks.
Mom,
No
I'm really
homework.
sorry.
You haven't submitted any homework, Zoha. I was checking today also. I haven't received any of your homework. Please
Yeah.
submit it, Zoha, so that we can discuss something. Okay.
I'm sorry, Mom, but I've been really busy with the upcoming examinations. I wasn't getting time. I also have to submit projects and homework in school, so I
Okay,
wasn't getting
Zoha.
time.
So whenever you get time, at least try to complete your homework
Yeah, I
question.
will try to do it.
Yeah. Okay. Okay. Let's start writing it from here.
Yeah, okay. Can you scroll down? Can you scroll down? Can you scroll down? Okay, ma'am. I finished.
Okay, Zoha. So the time is up. I'll complete this in the next class now. On Sunday, let us complete. So this chapter will be over on Sunday, and most probably we'll be able to start with human eye. But I think I'll prefer to start human eye on Monday. I'll try